Hello and welcome to today's lesson where we are just going to look at matrices. All right. Today we're just going to concentrate on matrices. Specifically, we're going to revise through grade 12 past paper questions, okay, selected past paper questions, where we are going to really consider how we can go about when solving matrices. So as you can see displayed on your screen, there is the topic on matrices. All right, let's jump into the slides and see what is there for us. Okay, as you can see, that is grade 12 ECZ exam questions only. Okay, here we are. Let's look at the lesson objectives. So the lesson objectives for this lesson are that 1, by the end of this lesson, I trust and believe that learners or viewers should be able to do the following: find the determinant of a 2 by 2 matrix, find the inverse of a 2 by 2 matrix, find the unknown value given the determinant, understand the meaning of a singular matrix. Okay, we need to understand the meaning of a singular matrix. Okay, let's proceed. Okay, before we go on to look at the exam questions, maybe just to remind ourselves about the determinant of a 2 by 2 matrix, because this is very important. So if A is a matrix, okay, if A is a matrix there, then det A is equal to AD minus BC. That simply means AD, these are elements in the major diagonal minus elements in the minor diagonal. Okay, so let's proceed. Now, let's just remind ourselves about the inverse of a 2 by 2 matrix, the inverse of a 2 by 2 matrix, okay? If A is a matrix, A with entries A, B, C, and D, then we're saying the determinant of A is going to be K, or if we let the determinant of A equal to K, okay, then the inverse of A is going to be 1 over determinant, okay? Elements in the major diagonal, swap positions, elements in the minor diagonal, okay? We'll just change the signs there. If they are negatives, they become positives. If they are positives, they become negatives, all right? So therefore, since the determinant is given by K above there, so we're saying the inverse of this matrix is going to be 1 over K. Okay, elements in the minor diagonal, change signs, elements in the major diagonal, swap positions there. All right. Let's go into another slide. Let's just remind ourselves about a singular matrix. Let's just remind ourselves about a singular matrix, what it really means when we say this matrix is singular. A matrix is singular if its determinant is 0, it has no inverse. Okay, so that simply means a matrix is singular if it has a 0 determinant. And by the way, a 0 determinant, a matrix with a 0 determinant has no inverse. That's the implication there. A matrix that has got a 0 determinant, it simply means that matrix has no inverse. Let's proceed. Therefore, a 0 determinant, like I've already said, has no inverse, and it is called singular. So different examiners will choose to phrase questions there using different terminologies. For example, another examiner may say, maybe find the value of x for which this matrix has got no inverse, or another examiner may simply say for which the determinant of this matrix has no inverse, or for which this matrix is singular. Okay, let's jump into another slide and see what is there for us. Oh, that's great. If you are new to this channel, you are most welcome. Support this channel by clicking like, okay? Just by clicking this thumbs up there, click the like and subscribe icons. Don't forget to hit the bell notification so that each time I upload a new video, you'll be the first one to be notified. Kindly just hit that bell notification and click on notifications for all. Okay, so to those of you who are new, I welcome you with all my heart. You are welcome. This is a channel for you. Please let's share these videos and make sure that this channel grows. Okay, your support is highly appreciated. All right, let's just proceed. Okay. Straight into ECZ exam questions. Okay, straight into ECZ exam questions. Here we're going to look at this question that came in 2019 internal paper. Given that matrix A is equal to 6, 3, 2, and x there, okay, find the value of x for which the determinant of A is 36. Hence, find the inverse of A. All right. This is our matrix that is presented to us there. So what are we going to do here? You will discover here that, okay, we have been told that the value of x, we've been told to find the value of x for which the determinant of A is 36. Let's proceed. Okay, here we are in the solution slide. Now, determinant, the formula for determinant is AD minus BC. This AD simply means elements in the major diagonal minus elements in the minor diagonal. Okay, so the determinant there has been given to us as 36. So we are simply saying 36 is equal to 6 multiplied by 3. These are elements in the major diagonal. Minus 2 multiplied by x. These are elements in the minor diagonal. Okay. So 36 is equal to 6 by 3. There we get 18. 2 by negative 2 by x, we get negative 2x. Note that this is the same as 18 minus 2x is equal to 36. So order should not confuse us there. All right. Let's proceed with our solution. Therefore, if we allow x to remain on the other side, those variables with x to remain on one side, those without x's, they go on one side. We solve this equation. We're simply saying 36 minus 18 is going to give us negative 2x. So 36 minus 18, which is going to give us 18. So negative 2x is equal to 18 there. So to remain with x, we divide now both sides by negative 2. Okay, which is going to give us the value of x is equal to negative 9. All right. Now, part 2 of the question is requesting us to find the inverse of the matrix A. So the inverse of the matrix is given as 1 over determinant. Elements in the major diagonal, they are swap positions. Elements in the minor diagonal, they change signs. Okay, so now the matrix, since we found the value of x, we can just substitute that x in our matrix. So we're going to have our matrix as 6, negative 9, 2, and 3 there. 6, negative 9, 2, and 3 there. So you will discover now that the inverse of this matrix is simply going to be A inverse is equal to 1 over determinant. The determinant has been given to us as 36. So elements in the major diagonal here, they'll swap positions. 3 is going to go where 6 is, and 6 is going to go where 3 is. They've swapped positions. Then elements in the minor diagonal will just change signs. So they'll maintain the positions, but changing the signs. So this positive 2 here to become a negative 2. This negative 9 there, here to become a positive 9. Okay, you can leave your answer just here as this one is also correct. This is the factorized version, but others, they really go for expanded versions where they'll multiply now 1 over 36 by 3 and 1 over 36 by 9, 1 over 36 by 2 there. In short, we're multiplying this by everything in the matrix there. That one is an expanded version. But whether you leave it here or you go for an expanded version, really the result is just the same. Okay. So that's it. Okay, let's just jump into another slide and see what is there for us. Please, if you are liking this video, kindly give it a thumbs up. Give it that thumbs up and really subscribe to this channel. All right, let's proceed. Let's look at this question that came in 2019 GCE. 2019 GCE. The determinant of a matrix Q is equal to 8. The determinant of a matrix Q, of which matrix Q is equal to 8, 12, x minus 4, and x is 8. Find the value of x. Okay, so here we've been given that the determinant for this matrix is 8. Now, what will be the value of x? And having found the value of x, now we can go on to find the inverse of this matrix there. That's great. Okay, let's proceed. Okay, here we are into the solution slide. Okay, here we are into the solution slide. All right. Now, the formula comes first. So determinant is equal to major diagonal minus minor diagonal. Elements in the major diagonal, less elements in the minor diagonal. That is the formula for determinant there. So now we are simply saying the determinant has been given to us as 8. So 8 is equal to 8 multiplied by x. These are elements in the major diagonal. Minus 12 multiplied by x minus 4. Elements in the minor diagonal. Okay. So this one becomes 8 is equal to 8x minus 12x plus 48. So this is the 8x there, which is giving us this 8x there. Then minus, so 12x minus 12x, this is negative 12 multiplied by x. Now we are going to have 12x, then negative 12 multiplied by negative 4, we're going to have 48. Note that this is the same as, so where order is concerned, this is just the same as negative 4x is equal to 8 minus 48. So which is going to give us negative 4x is equal to negative 40. So dividing both sides by negative 4, we are going to remain with x is equal to 10. That's the value for x there. I hope we are really getting the how we are finding these solutions. Okay, now having found that, let's go ahead and find the inverse of this matrix. Okay, so the inverse of matrix Q is just 1 over det Q. Okay, that formula there. So meaning elements in the major diagonal swap positions, elements in the minor diagonal, they change signs. So we've been given we have determined that the value for x here, the x that was missing, is 12. So we can substitute there in the expressions. So this becomes our original matrix. Now, what would be the inverse of this matrix? So the inverse of that matrix now becomes 1 over det Q, okay, multiplied by that there. So that is the solution. This is our answer there. Okay, so simple. Just remember that to find the inverse, we are just swapping elements in the major diagonal, and we are changing signs for elements in the minor diagonal. Meanwhile, expressing this as 1 over the determinant. Okay, that's great. Let's look at another question. Okay, here we are into the slide where we're looking at 2018 internal paper. This question came in 2018 internal paper. Now, given that matrix A is equal to 4, 2, negative 5, and 1, okay, and B is equal to 8, Y, 3, and 5. This is an interesting question. This question is so interesting. Please pay particular attention to it as we just go through it together. All right, find the value of y for which the determinants, take note of that, for which the determinants of A and B are equal. All right, hence find the inverse of B. Now, this is so great in that you discover that the two matrices have got the same determinant. So meaning that for us to find the value of y here, we are going to use the determinant of the matrix A, because we've been told that the determinants of the two matrices are the same. So if you find the determinant for matrix A, that is the same determinant for matrix B. All right, so let's just jump into the solution slide. Okay, here we are into the solution slide. So here, dit A is equal to dit B, as I've already alluded to that. So we use matrix A to find the determinant and then proceed to find the value of y. I hope this is helping somebody to really connect things here. Therefore, the determinant formula is going to give us major diagonal elements minus minor diagonal elements there. So 4 by 2, these are elements in the major diagonal for matrix A, of course, and then minus 1 by negative 5, these are elements in the minor diagonal for matrix A. So let's proceed. Therefore, dit A is going to give us 8. Now, this negative there, multiply by the negative in the brackets. So this negative multiply that negative, we're going to have a positive there. So in short, we're going to have 8. 4 by 2 is 8. And then we're going to have negative multiplying negative, which is going to result into a positive. Therefore, the determinant for matrix A, which is also the determinant for matrix B, is now going to give us 13 there. Okay, so hence dit A is equal to dit B, hence the determinant of dit B is going to give us 13 there. That's great. Okay, that's great. So therefore, dit B is equal to 8 multiplied by 5. Okay, these are elements in the major diagonal for matrix B, minus 3 multiplied by y. So we proceed as follows. So this one continues. Solution continued. 13 is equal to 4 minus 3y. Okay, that means 13 minus 4, 40. 13 minus 40, that one was supposed to be 40. So 13 less 40 is going to give us negative 3y. Okay, hence negative 27 is the result of 13 minus 40, so this is going to give us negative 3y. So to remain with y there, to solve for y, so what is happening is I'm going to divide both sides of this equation by a negative 3, right? Hence resulting into my y being a 9. That's great. Well, solution still continues. Okay, solution continued. Now, to find the inverse, we are simply saying the inverse of matrix B, we are simply saying we are going to have 1 over dit B, then change elements there, like I've already said it over and over again. So this one becomes more like our formula for finding the inverse, which is really easy to handle. So since the value of y is given has been found as 9, so we can now really take matrix B to be 8. The missing part there has been now found, and that is 9. So 8, 9, 3, and 5. So meaning the inverse of this matrix is going to give us 1 over 13. Okay, 5, negative 3, negative 9, 8. Okay, so elements in the major diagonal, they change positions. Okay, you can see here 8 and 5 changes positions, or they swap positions. Then elements in the minor diagonal, they simply change signs. As simple as that. If you can understand this, then you are good to go. All right. So take note, do not confuse the value of y with the determinant of b. Okay, the value of y we found was 9. So don't express this as 1 over 9. No. The determinant has been found as 13 and the value of y has been found as 9. So the two should be treated separately. All right. We proceed. Okay, great. Let's just look at what is next. Okay, so let's look at another question there, which is 2020 internal paper. Given that the matrix A is equal to 5, 2, 2, and x, find the value of x for which A has no inverse. Yeah, really. Now you can see here, now we are being tested on a singular matrix. Okay, like I said in my opening remarks, when we're looking at singular matrices, examiners are going to really use different phrases there. Sometimes they may use for which the determinant has no inverse, or for which the matrix has got a zero determinant, things like that. So it is very important for you to understand the terminologies that are being used by different examiners there. So given that the matrix A is equal to 5, 2, 2, and x, find the value of x. Okay, find the value of x for which this matrix here has no inverse. Okay, find the inverse of A if x is equal to 1. Okay, so let's proceed into the solution slide. Let's just jump into the solution slide. Okay, solution. So since matrix A has no inverse, its determinant is 0. That is a very important property to understand and to be noted. Since here we are simply saying the matrix has no inverse, so we are simply saying its determinant is going to be 0. Okay. So 5x, 5 by x minus 2 by 2 is going to give us 0 because this matrix has got no inverse. So 5x minus 4 is equal to 0, as you can see there. So 5x is going to be, so we can solve this equation. We permit 4 to go this side of the equation. So we're going to have 5x is equal to 4. Okay, so x is going to give us 4 over 5 when we divide both sides by 5. That's great. Okay, so the value of x sorted. Okay, solution continued. So if x is equal to 1, okay, now we are on the part 2 of the question. So if now x has been given to us as 1, okay, then the matrix becomes matrix A is going to be 5, 2, 2, 1. Now here specifically x has been given to us. So we can now find the what has been requested of us to find. So that simply means determinant is going to be 5 by 1 minus 2 by 2 there. So 5 multiply 1, these are elements in the major diagonal, minus elements in the minor diagonal. Okay, so this one is going to give us 5 minus 4, which is going to give us the determinant of 1. So since the determinant there is going to give us 1, you now discover that the inverse is going to be 1 over 1. Then elements in the minor diagonal change signs, elements in the major diagonal swap position, they exchange positions. All right. So this one is just going to give us 1, 5, negative 2, and negative 2 there. That is your solution. That's great. I hope so far so good. If you are enjoying this video, kindly subscribe, like, share this video, tell somebody that really things are happening, and let's make sure that this channel grows. Great. In conclusion, please don't forget to like, subscribe, and hit that bell notification to help this channel to grow. Okay, thank you so much for watching. Really, you have been a blessing to me. God bless you and shalom.